Hey there, Algebra 2. This is Brave School for Unit 10. Okay, just remember that as you go through this, you are going to be asked questions as you go along. They're going to stop you. You guys have done edge puzzles before, not just in this class. And in those questions, I'm going to ask you to do a practice problem. So I'll be reviewing the problems as we go through, and I'll have you practice them. Okay, those practice problems need to be done on a separate sheet of paper. Okay, some nice lined paper. That is what is kind of like your ticket to retake the test, because we want you to use this in order to get better. But also don't just use this. Go over these problems in the ed puzzle and then come and see Mr. Osborne or Mr. Kershaw for help to review the stuff that you still don't understand. Okay, the idea behind the ed puzzle is not to make you 100% smarter, but hopefully 50% smarter or 60% smarter. And then at least you'll be able to go over just a few things instead of the entire test. Okay? So let's get started. So, oh yeah, and also just remember you're free to skip around. You don't have to watch the entire video. You watch what you need. If you don't know how to do a certain problem, then watch how to do that problem. If you do know how to do it, go ahead and do it, and then move on to the next one. All right, so number one, and this is test review day 1 worksheet that I'm going over. Okay, so first it says find the missing side, and then find all 6 trigonometric functions for theta. Well, first just find the missing side. And to find the missing side, we simply use Pythagorean's theorem, which is a squared plus b squared equals c squared. So I know that 10 squared plus, well, the missing side is b, because I know it's opposite b, so it's little b. So 10 squared plus b squared equals 13 squared. And so 100 here, b squared equals 169. And then let's subtract 100 from both sides. And we do that because we're trying to isolate b. And now we have 69 over here. And then the last step you want to do is take the square root of both sides. You take the square root, and then you get b equals roughly, let's put a little about or estimate sign, estimation sign, approximate sign, and put about 8.3. And we'll use 8.3 for all these ratios. Okay, so now what you need to do is we are going to find the ratios for theta, which is this angle we do not know. We're going to find all 6 of them. Okay, for sine, cosine, tangent, cosecant, secant, and cotangent. Okay, zoom in a little bit so you guys can see that better. Okay, so for sine, remember that it's opposite, the opposite side over the hypotenuse, so that would be 10 over 13. So that's the ratio for sine. Cosine is the adjacent over the hypotenuse. And remember, the adjacent is that number we just found, 8.3. So then 8.3 over 13. And then for tangent, it's going to be opposite over adjacent. So 10 over 8.3. Some of you guys are saying like, oh my gosh, this was so much easier than I thought it was. Okay, now for cosecant, secant, and cotangent. Remember, these are the cousins to these ratios on the left. Okay, to remember which one is related to the other, remember that the letters are not the same. So for sine, its cousin is cosecant, which has a C. And for cosine, its cousin is secant, which has an S. Because you would think, oh, well, sine must go with secant because they both start with an S, right? But it's actually not that way. So I always remember that sine goes with cosecant because it does not have, they do not share the same letter. Okay, and then tangent and cotangent are always the most obvious ones that go together because they both have tangent in the word. Okay, so cosecant, remember, is the same thing as sine, but it's 1 over that ratio. So in other words, all we're doing is taking the reciprocal. We're flipping it. Okay, and then secant is the same thing as cosine, but then taking the reciprocal of that. So then the same thing flipped, 13 over 8.3. And then again, the same thing for cotangent. It's tangent, it's the reciprocal of tangent. So it's the same thing flipped, 8.3 over 10. So once you know these ratios, you know it's these ratios, you know what these are, because it's the same, it's these first ones that are flipped. Okay? So now let's go to this one. So again, 10 squared plus 11.8 squared equals c squared. 100 squared. I don't know what 11.8, oops. I don't know what 11.8 squared is. So let's do that on the calculator. And actually I'll do the whole thing. So let's actually take the square root of that. I'll just do it all together. Do it all at once. Save yourself some steps. And then we'll figure out what c is. I hate it when it does that. Stop doing that. Alright, so now we're going to do the square root of 100 plus 11.8 squared. And that looks about right. And the square root of all that. And that equals 15 point, let's round it to the nearest, we'll say 100th. So 15.47. Okay, so 15.47. Okay, so now that missing side is 15.47 there. Okay, now for sine, again, opposite over adjacent. So 11.8 over 15 point, let's go to the nearest tenth, since we have a tenth up here. So we'll do 15.5. Okay, and then cosine is going to be the adjacent side over the hypotenuse, so 10 over 15.5. And then tangent will be the opposite over the adjacent, so 11.8 over 10. And then cosecant, which is the cousin to sine, is the same thing, flipped. So 15.5 over 11.8 this time. And then secant is going to be 15.5 over 10, because remember it's the same thing, flipped. And then cotangent is going to be 10 over 11.8. All right, and that's it. Okay, so now find the missing lengths. Okay, this is where you want to set up your ratio. And you got to recognize that this is a 90, 60, 30 triangle. So I'll set up my ratio, 30, 60, 90. Okay, and remember the ratio is for 30, 1. For 60, 1 times rad 3. And for 90, 2. Okay, so now the only side I know is this side 12, which is opposite 90. So I'll put it under 90. So we'll put equals 12. And then for 60, the side opposite 60 is x. So we'll put x here. And then the side that is opposite the 30 is the y. So we'll put y here. So we'll do one problem at a time. Okay, so let's remember you set this ratio up, and then what you do is you cross multiply. So now 2 times x, and then 12 times rad 3. And I'll divide both sides by 2 to get rid of that 2. And x equals, looks like 12 divided by 2 would be 6 rad 3. Okay, so that's our x. Okay, and now that I know this side, I can set up the ratio for the other one. So this one, I'm going to cross multiply these two. Okay, and I know now that this side is actually 6 rad 3, so it's not x anymore. So it'd be 1 times 6 rad 3, which is just 6 rad 3. And then y times rad 1 rad 3, which would be just y times rad 3. But then we need to get rid of this rad 3 on this side, so divide both sides by rad 3. That cancels out, and y equals 6. And so that side is 6. Okay? So that's how you solve those. You got to set up your ratio. Okay? And it's going to be the same thing for this one on number 4. Set up your ratio and cross multiply. Okay? Actually, I'll go over that one because the steps are just a tad bit different. So again, set up your ratio. Okay, so we have 1 rad 3. I'm going to go a little faster this time. And the side opposite 60 is the one we know. So it'll be 5 there. And then the one opposite 30 is going to be v. And the side opposite 90 is their u. Okay, so let's start with this one first. So we'll do cross multiply there. We get v times rad 3 and then 5 times 1. And we're going to divide both sides by rad 3, and this is where it gets a little bit different. Because if you notice, I cannot have a radical on the bottom in the denominator. So what do? Multiply the top and the bottom by rad 3. Okay. And what that does is on the top, yes, we still have 5 times rad 3, but now if you multiply this rad 3 times rad 3, it just becomes 3. And now we don't have a radical in the bottom or in the denominator. Okay, and now we can set it up for the last one, these two. And now we have 5 times 2, which is 10. And then u times 1 rad 3, which is u times rad 3. Divide both sides by rad 3. And again, same thing here. You have to multiply top and bottom by rad 3. And now u is equal to 10 times rad 3 over 3. Okay, so those are a little bit different just because we have to cancel out or get rid of that radical. Okay, so now, here for number 5. Number 5, you want to set up the ratio again. Except this time you have a 45, 90 triangle. So 45, 45, 90. And now the ratio here is 1 for the 45 degree angles, and then 1 rad 2 for the 90 degree angles. Set up your ratio, plug in the sides that you know, and you know that these sides are A and B, and then this one is 6. And the nice thing about the 45, 45, 90 is that once you find one of the sides that's opposite the 45, then you know the other because they're the same. So all you have to do is solve for one of them. Okay, so here, cross multiply here, so I'll have B times rad 2, and then 6 times 1. Do the same thing like I did before. Cancel out that, or get rid of that rad 2 by dividing it on both sides. And then I can't have it in the denominator, so I'll multiply top and bottom by rad 2. And now I have 6 times rad 2, and then this becomes 2 in the bottom. But again, don't forget, this 6 and 2 can cancel out, so it becomes 3 times rad 2. Okay, so now A is 3 rad 2, and so is B, because remember, they are the same in a 45, 45, 90 degree triangle. Okay? Okay, so number 6, again, set up your ratio. One rad 2. And this will be M, this is N, and then this side is the 4 times rad 2. Okay, multiply here. We'll go up here to this spot so we have more room. N times rad 2 equals 4 rad 2 times 1. Divide both sides by rad 2. The rad 2's on both sides cancel out, and it equals 4. So that means this side is 4, and M is 4. Okay, done. Okay, now this one. Now remember, when you go through this, you got 3 different things you have to do for this problem. The first is draw the angle. Okay, so these are the angles you're going to draw, the 120 and the 135, or sorry, the 315. So first let's do that. So, and you kind of just have to draw roughly where that, they don't have to be exact. Kind of draw roughly where you think they are. Now 120, I know it's not right in the middle. It's here in the second quadrant, it's not right in the middle. It's a little closer to the y-axis, so maybe like right there. Okay, so there's 120. That's the first step. Now this is where the points come in. What matters? First thing you want to find is the reference angle. Okay, because you're just going to use that 120 as kind of a point of reference to figure out the other two angles, the reference and the coterminal. Now remember, the reference angle is how far this angle is from the x-axis. Okay, remember, here on the x-axis, at this point it's 180. So you're going to figure out how far in degrees is it from the x-axis. Well, from 120 to 80, it's 60 degrees. So that's your reference angle. So we'll just put REF angle here. Actually, we'll do it this way. Do a little angle there. And REF for this one is 60. And it's just simply how far is it from the x-axis. So even if it's below the x-axis, it's still how far is it from there. And it's always going to be positive. Okay, so now the coterminal angle. And let's call this the negative coterminal angle, because that's how we say it on the test. So negative coterminal angle. Okay, and that's not cotangent, it's coterminal. Okay, the coterminal angle is an angle that meets at the same point, or at this same point where 120 is, but it doesn't go in this direction. It doesn't go counterclockwise. It goes in the clockwise direction. So it starts at the same point and ends at the same point, but then goes the other direction. So that means it went further. In other words, it's, in a sense, kind of a bigger angle. But because we went the other direction, we consider that a negative direction. Now to find that, what you're going to do is do 120, our original angle, and if we subtract 360, that will tell us what the negative angle is. So negative 240. So simply, if we ask you to find this negative coterminal angle and you subtract 360, boom, you have it. Okay? That's all there is to it. Okay? Or you can count it. You can say, okay, I know from here to here is 180, and then to get all the way to 120, I add another 60, and that gives me 240. But then I know if I'm going this way, it's negative. Okay? Okay, so now the next one, we'll do it just the same. So again, let's draw our 315. The 315 is in the fourth quadrant, and it's right there in the middle. Okay. And remember, you have that posted up on the board too, where 315 is, so you shouldn't get that part wrong. That's why you don't even really get points for it. You get points for the reference angle and the coterminal angle. Okay, so first the reference angle. Again, how far is it from the x-axis? Okay, and here, from 315 to this point would be 360. It's going to be 45 degrees. Okay, so you're just finding the difference here. So here I would basically, if I want to do it mathematically, it'd be 360 minus 315. Or over here, it'd be 180 minus 120. Okay, so now for the negative coterminal angle. Now remember, the original angle goes off in the counterclockwise direction, but the coterminal angle goes in the clockwise direction, so from here to here. So it didn't really go that far. And guess what? It's almost the same it's the same distance as our reference angle. So it's negative 45. Okay. Oh, I didn't even write down what the reference angle was. Reference angle is 45 degrees, and here our negative coterminal would be negative 45 degrees. Okay? Remember, the reference angle is always positive. And the coterminal angle, if I ask for negative coterminal angle, this should be negative. Okay? And again, you can get that by doing 360, or sorry, not 360, 315, the original angle, minus 360, and you'll get that same negative 45. Okay? Now to convert each measure into radians. Okay, so for 225 degrees, or for any degree, we multiply the number times pi over 180, or pi over 180 degrees. So now it's 225 over 180. And remember, we don't want to get a decimal answer. We want to leave it as a radical. Or not even a radical, but we want to leave it in a fraction form. So let's do our best to reduce it. Okay, so the first number that comes to mind here that I can multiply into both, or divide into both, would be 5. So 225 divided by 5. Got my calculator over here. 225 divided by 5. That'd be 45. And I still have pi on top. And then 180 divided by 5 is 36. And then I know 9 can go both into 45 and 36. So if I divide 9 into 45, that would be, it would go 5 times. Oops. Again, we still have that pi on top. And then 9 goes into 36 4 times. So it would be 5 over 4 pi. Okay, same thing for 330 times pi over 180. Okay, 330 over 180. And then I know that 30 could go into both of 330 and 180. So if I divide each of these by 30, then I'll have 11 on the top, 6 on the bottom, and pi. So 11 over 6 pi. Now for converting radians to degrees, you still multiply, but not pi over 180. You're going to do 180 over pi. And you'll notice that the pi will always cancel out. And now you're just going to multiply 13 times 180 and then divide by 12. Do that here on the calculator. So now 13 times 180 and divide by 12, and we get 195. So 195 degrees. Okay. Now this one, same thing. 180 over pi. Pi's cancel out. Now it's going to be 180 divided by 18. Oh, sorry. And I know that 180 divided by 18 would actually just be 10 degrees. Okay. Alright, so now let's go down here. Okay, now this is where you need to use the unit circle. So let me get a unit circle. So I'm actually going to use the template I used for the test. And here's my unit circle. So we're going to use this as reference. So you might want to bring out your notes when you do the problems that I give you. Okay, so first we need to find the sine of 240 degrees. So go to unit circle. Oops, not that one. And go to 240. And remember the sine is the y value, so it's going to be negative rad 3 over 2. So the answer is just simply negative rad 3 over 2. Okay, and then let's say we'll do the cosine at 315. Okay, so the cosine again is the x value, so go to 315 degrees, and it's the x value, so rad 2 over 2. Alright, so now let's go over a couple that probably aren't so obvious. So how about tangent? Tangent of 300 degrees. Well, remember tangent is going to be sine over cosine. Okay, so I go to 300, and it's going to be this value, negative rad 3 over 2, divided by 1/2. Now, maybe you've done the math before already, and you know what that's equal to, because we use it so often. But if you don't, just go ahead and write it out. Okay, so rad 3, sorry, it should be negative rad 3 divided over 2 divided by 1/2. Remember that with fractions, when you divide them, you just flip the second, and now it becomes multiplication. And we have a 2 on the top and the bottom, so those cancel out. And now it's just negative rad 3 over 1, which is this equal to negative rad 3. Okay. Now, how about another one that's not as obvious? Again, how about, all right, we'll just go to cosecant. Cosecant of 270. So find 270. All right, 270 degrees is right here. And at 270, the cosecant is the cousin to sine. So that means 1. That means that sine at this same 270 would be negative 1. And then remember, cosecant is the same thing flipped. So now, instead of negative 1, it becomes 1 over negative 1. But guess what? That's still the same thing, negative 1. Okay, so now let's look at secant, which is the cousin to cosine. So go to your unit circle, 45 degrees. And the secant is the cousin of cosine. And cosine at 45 is rad 2 over 2. So let's go back here. And remember, it's going to flip it. So now it's 2 over rad 2. But then again, we don't like the radicals in our denominator. So just multiply the top and bottom by rad 2. And now it's 2 rad 2 over rad 2 times rad 2 is rad 2. But then these 2's cancel out. So then it's just simply rad 2. Okay? And now when you see the radians, you're going to do the same thing. So let's do cosine of 2 pi over 3. Go to 2 pi over 3, find that on here, and here it is at 120 degrees. And we're looking for this cosine, so that's the x value, so it's negative 1/2. And if you're doing, let's say, okay, here's one's a little bit different. How about cosecant of negative pi over 4? Well, go to the graph. Negative pi over 4, well, positive pi over 4 would mean I'm going the counterclockwise up to pi over 4. But negative pi over 4 would mean I'm going down the other direction. Okay, and pi over 4 is 45 degrees, so that means this is negative 45 degrees, which puts us right here. Okay, so that means right here at 315. And again, what were we looking for? We're looking for the cosecant. Remember, cosecant is the cousin to sine. So we look at the sine here, and we're going to flip that. So negative rad 2 over 2, we're going to flip it. So negative rad 2 over 2, we're going to flip it. Now it's negative 2 over rad 2. And we already did the math when we flipped rad 2 over 2, and it came out to rad 2 here. So I don't have to do the math again. I just know that this one's going to be negative instead because we have a negative to start with. Okay? So that's how you do those. All right, so now let's go down to this one. Now find the area of the triangles. This is the last one for this first worksheet. Okay, so what we want to do here is if I have an angle and two sides that are adjacent to that angle, in other words, two sides that are right next to it, I'm going to use my area formula. And let's show you what's posted up there. It would be this one here. Area is equal to 1/2 times b times c times sine of a. The b and the c are the sides that are adjacent or right next to the angle that we have. And then the a is just the angle that we have, which in this case happens to be 110. So let's set this up. So area is equal to 1/2 b times c times sine of a. And now we're going to plug in our values. So the first value for b would be 15.8. And then times 14 times sine of 110 degrees. And you just plug that in the calculator and figure out what it's equal to. Okay, so let's go to our web calculator and let's type in 1 divided by 2, and then when we press times 15.8 times 14 times, make sure you hit that times button so it knows what you're doing, and then times the sine of 110 degrees. And that looks just how I set it up on the paper. So that looks good. So give me my answer. And I get 103, and we'll round to the nearest 100.93. Okay, so 103.93, and then don't forget units. It's measured in feet, and we're talking about area, so it's 103.93 feet squared. Okay. Okay, you'll do the same thing with this problem here because you have an angle and two sides that are adjacent. Okay, but I'm going to move on to this one down here. And these two problems are done the same as well, because now you're given three sides, and you don't do them in the exact same. But here we're going to use what we call Heron's formula. And going back to our little formula sheet, that would be these formulas here. First we have to find the s, and then we plug in the s, and then that will give us our area. Okay, so first we need to add up all the sides and multiply it times 1/2. So in other words, find half of the perimeter. So our s will be 1/2 times all the sides added up, or a plus b plus c, okay, so now 1/2 of 12 plus 9 is 21, and then 21 plus 12 would be 33. Okay, and then half of 33, or 1/2 times 33, would be 16, no, 17, all right? No. It'll be 16.5, okay, or 16.5 miles. Okay, now we're going to plug that number into our equation. So first you plug in 16.5 times 16.5 minus, it doesn't matter what number you pick first, just pick one, or what side, minus 9. Then you're going to do 16.5 minus another side, and then 16.5 minus the last side that you didn't subtract, okay? And then you can just simply just plug that into a calculator and get your answer. So now, let's plug that in. So first the square root of 16.5 times, and I'll use parentheses, 16.5 minus 9, and then 16.5 minus 12, and then 16.5 minus 12 again. And that looks like how I want it to be set up in the calculator, I believe. Oh wait, no, it didn't like something there. So let's do times 16.5 minus 12. Seems to like it when I do the little asterisk multiplication. Doesn't like when I don't do it. Okay, that looks good. Okay, so now we're going to have 50.06. So 50.06, and then look at the units. It's in miles, so miles squared. And again, you're going to do the number 28, the triangle. So for number 1, and just remember, when we get our answers, round to the nearest hundredth. Okay, 2 places after the decimal. Just keep that in mind as we work through this problem. Okay, so for number 1, the first thing you want to try is law of sines. Try that first, and then if you can't do that, then you want to try law of cosines. Okay, so first let's try to set up law of sines. In order to do that, I need a pair of an angle and an opposite side, and I have one, so I can set that up. Now again, be careful on how you set it up, because you can put the side on the top of the sine, or the ratio, or you can put it on the angle on the top. In this case, we're going to look for a side. We're going to look for side C. So we're going to put the side on the top, side C, and then the angle opposite that is 105. So we take the sine of that, and then we're going to match that up with a pair that we know, which is the 36 degrees and 28 kilometers. And remember, I put the side on the top, so that means I need to put the other side on the top. And then the angle, or the opposite angle, I will take the sine of below. Now again, just like I told you guys in class, what we're going to do here is cross multiply. But the nice thing is I can just take this sine of 105 and place it up there and multiply it times 28. So now when I rewrite this, it will be C equals sine 28 times the sine of 105 divided by sine of 36. Now some of you guys were asking me in class, well, what's the best way to practice this at home? Like, what calculator should I use? Well, what I would do is, if you don't have one, or a graphing calculator, is go to Google and just type in calculator. So calculator. And as you type in calculator, you'll see it pop up. And don't use the Google calculator, but use the one right below it, that first link that says Web 2.0, scientific calculator. This one's going to best help you more than the other one. Okay, and it will set these up. Okay, so now the first problem is going to be 28 sine of 105 divided by sine of 36. So 28, oops, let's bring this down here, bring it up here so we can get it out the way. 28, and then sine 28 times sine of, what was that, of 105, and parentheses around that, and then divided by sine of, what was that, 36? That's 36. Oops. Backspace. And you can backspace by clicking this little backspace button. 36, and then parentheses. And what you'll notice is that up above, it sets it up for you, so you can see that you did it correctly. Okay, so then that way I can see that that matches up with how I wrote it down. Okay, go ahead and press enter, and I get, 46.01, we'll round that to nearest hundredth, so 0.01, 46.01. Okay, that's side C. Okay, but I still need to find side A and then angle A. All right. Okay, well, I know angle A. I can find that because I know that the angles of a triangle add up to 180. So 180 minus 36 plus 105. Do that in the calculator. Oops, sorry, I'm trying to move to this. Okay, clear this. So now it'll be 180 minus, parentheses, what was that? 36 and 105. So 36 plus 105, put that in parentheses, and I get 39. So the difference is 39. So that other angle, angle A, 39 degrees. Okay, there's one. And now the last thing I need to find is side A. Okay, and I just use, again, law of sines to set that up. Zoom out, give myself some room. Okay, I'm looking for a side, so we want the side on the top. And the opposite angle is A, which is 39, so we do sine of 39. And then I just pick a pair that I already know. And I'll use the same one I used in the beginning, 28 over sine of 38, or 36. Okay? And again, do the same thing like we just did before. Cross multiply, and I'll bring up this sign to the top. So now A is equal to 28 times the sine of 39 degrees divided by the sine of 36 degrees. Okay, now let's do that on the calculator. So now clear that. 28 times the sine of, what was that? 39, sine of 39 over sine of 36. So sine of 39 divided by sine of 36. Oops, not 39. 36. And just to double check this, make sure I set it up right. Look at how it's laid out. And it looks good. And so my answer is 29.97, but then the 8's going to make me round up 1, so 29.98. So then A is equal to 29.98 kilometers. Remember, it's measured in kilometers. And we're done. Okay? Now the next triangle, you will solve that the same way. You do it the same way because it's the same situation. We have two angles and one side. So again, you have this pair. There's your first pair. That's the one you're going to set up the sine with. So I'll set up the first one, but I want you guys to do that on your own. So again, I have a pair there, so I'm going to go ahead and set it up. But first of all, let's start with the side that we're looking for. This is little b. We're going to have to look for little b, little c, and angle A. Okay, and let's start with little b because we already know its opposite angle. So we're going to put the b on the top, equal to the pair that we know. 22, again, side on the top, over sine of 48. Okay, and then you solve that the same way like we just did before. Okay, so let's go to number 3. Okay, so now number 3, this time we have two sides and then an angle. Okay, Well, again, I've got a pair, so I know I can use law of sines here. Okay, so that means I need to look for little b, angle b, and angle c. Okay, so let's start off with little b. It's always easier to find the sides first and then find the angles last. So that's why I always start with the sides, if I can. Okay, and now if you notice, I've got a problem, because usually I put this over the sine of whatever the angle b is, but I don't know the angle. So, that's a problem, isn't it? So I only know one pair, so that means I can't choose that side to find. But I do know, the only other piece of information I do know is this 13. So in this case, looks like I'll have to find the angle C. Okay, because I have angle C and then its opposite side. So that's the only one I can look for first. So now sine of C over 13 yards. Remember, I'm looking for the angle, so I want the sine on top this time. And then now the sine of 91 degrees over its opposite side, 32. Okay, now again, the first couple steps are the same. Cross multiply, and that means I'm going to bring this 13 up here. So now it's the sine of C equals 13 times sine of 91 degrees over 32. But now, what I need to do here is that once I get to the point where I just have sine on this side of the angle, I will do the sine inverse of this value, whatever it is. 13 times sine of 91 degrees. And that will give you my angle C. So again, once you get to this point where you just have sine of the angle by itself equal to some value, or this expression here, you're going to take the inverse sine of that value, and that will give you angle C. So let's find that. So inverse sine of 13 times sine of 91 degrees over 32. So again, we need to pick the correct one here. So we're going to do sine inverse. If you notice, it's the negative one there. So in this calculator, I have to push second to get to that sign. Okay, and on this calculator, they call it a sine, which also means arc sine, which is the same thing. Okay, so arc sine of 13 times the sine of 91. We want to get rid of that. You see, I have to go back and forth, so I have to push the second again to get back to the regular sine. Oops. Forgot I got to do 13 times sine, so that it doesn't think I'm doing sine of 13. 91. And all that divided by, I believe, 32. Let me just double check. Yep, 32. And then look how it's set up and make sure it's exactly what you want. And yep, we have the inverse sine of 13 times sine of 91 degrees divided by 32. And it's calculating. I don't know what happened, but I just retyped it again. And I didn't change anything, but for some reason there was an error. But anyways, there's our angle, 23.9, and we'll round that 6 up to 7, so 23.97. Okay, so there's our first angle, 23.97. Okay, but remember, first we're looking for angle C, we're looking for angle B, and for side B. So we have an angle, and we can find the other angle by just simply doing 180 minus the other two angles added up, or the sum of the other two angles. Okay, so let's just add that up real quick. Okay, so now let's do 180 minus C's 91 plus 23.97 equals 65.03. Okay, so there's our angle B. (65.03 degrees). Now we just need to find side B. And this is where we can just use, again, sine. So law of sines. We're looking for angle B, and the opposite angle is 65.03, so sine of 65.03. And that's going to be, we're going to use the pair of 32 over 91. So we'll put sine of 91 there. And again, we're going to cross multiply, so we'll just move that sine of 65.03 to the right. And we get 32 times sine of 65.03 over sine of 91. That will tell us our last side. Okay, so let's clear this. Okay, so now we're going to do, is it 32 times sine of 65.03? 32 times sine of 60, oops, wrong button, of 65.03 divided by the sine of 91. Oops, 91. Okay, and that is our side B, 29.01. And that's in yards. So we make sure we note that as yards. 29.01 yards. Okay. All right. There we go. There's our answers. Got there, there, and there. Okay. Now the next one. This one is a lot like our first one. We had two angles and a side. However, the difference here is that there's no pair here. There is no pair there. And there's no pair there. So if there's no pairs, this is where we have to use the sine. I'm sorry, law of cosines. Okay, so again, we're missing little b, we're missing little a, and we're missing angle C. Okay, so let's write that down. Make sure that's what we look for. Angle C, side A, and side B. Okay, so we know when these angles, we know two of the angles, so we can find angle C easily by doing 180, so minus the others, or the sum of the others. Okay, so 180 minus 94 plus 23. We get 63. So first angle is 63 degrees. Okay, so now we just need to find that little a and little b. Okay, so now we've got a pair. So now we can just use that there. So actually we don't need law of cosines here. Okay, so now 25 meters over sine of 63 degrees equals, and we'll go ahead and find side A first. So put that sine of 23 over sine of 23 because the 23 is the opposite angle. And now we'll cross multiply. And again, I have a over here, so I can just multiply this sine of 23 and put it up here. If you notice, I started with a on the right instead of the left, like I did before with the variable, but that's okay, you can switch it. 25 times sine of 23 degrees divided by the sine of 63 degrees equals our a. So let's go ahead and plug that in. And I'll put a back here on the left once we figure that out. So 25 times times the sine of, let's see, 23 over the sine of 63 divided by the sine of 63. Oops. 66, 63. Looks good. So go ahead and press enter or equals, and I get 10.96. There's our side A. 10.96 meters. So make sure you say the correct measurement or notation. And the last one we need is B. Okay, so again we'll set up our sines, or law of sines formula. And B is opposite of angle 94. So we'll do sine of 94. And then we'll go ahead and use that first pair I used, the 25 and 63. So 25 over the sine of 63 degrees. Cross multiply, bring that sine up there. And now 25 times the sine of 94 degrees divided by sine of 63 degrees. Okay, so now 25 times the sine of, what was that again? 94 divided by the sine of 63 degrees. Okay, 27.99. So B is 27.99 meters. 27.99 meters. Okay, there we go. Okay, let's take a look and find one where we have to find with cosine, and that would be these cases here. Okay, here's a case. Let's compare it to the first one. We've got two sides and an angle. Did we have that before? No, the other ones we had two angles and a side. Here we had two sides and an angle. So yes, there was another case where we had two sides and an angle. However, in this case we had a pair, a side with an opposite angle. However, in this case where we just have two sides and an angle, we don't have a pair. So the angle C does not have a side opposite of it. Okay, so here we're going to need to find C. We're going to need to find angle A and angle B. Okay, so now this is the case where I definitely am going to have to use the law of cosines. Okay, and since I know an angle already, I'm going to want to use that angle in my first step. Okay, so that's the one I'm going to want to plug in. So if I have the angle C, that I'll set everything equal to little c, or side c. Because remember, it's going to be c squared equals a squared plus b squared minus that same a and b times 2, so 2ab, times the cosine of whatever you set it equal to, that same opposite angle. So if you set it equal to little c, you're going to do the cosine of big C. Okay, so let's go ahead and plug all that in. Okay, so we don't know little c. We know A is 24, and we're going to square it. Oops. And then we're going to add 24 to 26 squared minus 2 times those same sides, 24 times 26 times the cosine of 134 is our angle. Now the nice thing is, once you get to this point, since we know all these values on the right side, there's no variables here, we know the last step is going to be taking the square root. So to solve this, I can simply just square root this right now and plug all of that into the calculator without having to simplify and do all the steps. Okay, so now I'm going to plug all that into the calculator. See if I can get a split screen here. Aha! Perfect. Okay, so let's move this over so I can see it. Okay, so again, first let's do square root. There's my square root. And then we're going to do 24 squared plus 26 squared minus 2 times 24 times 26, and then times the cosine of, oh, it doesn't like that. Okay, so I have to do times here to make sure it recognizes that I want the cosine on the inside of the square root of 134. And there we go. Okay, then double check, look at how it laid it out, make sure it's exactly how you want it. I've got 24 squared plus 26 squared minus 2 times 24 times 26 times cosine of 134. Looks good. And then up with 46.03. Okay, and this was measured in yards. Okay, so there's our C, 46.03. And the nice thing is, once I found one side, let's see if I can get rid of this. There we go. Once I find one side using the law of cosines, then I don't have to use the law of cosines anymore. Then I can just use law of sines, because now I have a pair. Alright, so 46.03, so there's my pair now. So now I still need to find two angles. Okay, so let's look for angle A. So we do sine of A. Remember, if we're looking for the angle, we put the angle sign on the top, and the side opposite, that is 24. And then the pair we're going to use is 134 degrees, and its opposite side, 46.03. And then let's cross multiply. And we're trying to isolate this A, so let's just bring this 24 up here. So now 24 times the sine of 134 divided by 46.03. And remember, again, if we're looking for an angle, we're taking the sine of that angle and it's equal to some value, then we do inverse sine. Inverse sine of that same value, 24, times the sine of 134 divided by 46.03, and that should give us angle A. Okay, so let's plug that in. Zoom up on just that part. Bring up our calculator again. Okay, so now I'm going to do the sine inverse. So again, remember, for sine inverse on this calculator, you need to push second, then a sine, which is arc sine, the same thing as sine inverse. And now 24. And I'm going to have to multiply. And in order to get back to the regular functions, I had to push second again. Okay, so then 24 times sine of 134. And all that divided by 46.03. Okay, and that looks good. Looks like it matches what I wrote down. So equals 22.02. So my angle is oh, and let's see, that 8 is actually going to make my 2 round up to 3. So 22.03. So 22.03 degrees. Okay, so now there's my angle, or my first angle. Now I just need one more angle, and that's B. And I can simply find that just by finding the difference of 180 minus the other two angles, 134 plus 22.03. So let's bring up the calculator for that one again. Actually, we'll just split the screen, see if we can do that again. Aha, fancy. Move over to what I was working on. Okay, the 180. Okay, so 180 minus 134 plus 22.03. And it's 23.02. 23.97 degrees. There's our angle B. So I'll put that up here, 23.97 degrees. And there's our solution. Okay. Okay, and so the next triangle, you would solve that the exact same way. You'd solve that just like you did the number 5. Okay, you set it up just the same way. You have to use the law of cosines and set that up, okay? Okay, let's go to the back page. Okay, number 7 is just like the last one we did as well. Okay, this last few are the ones that are a little different. Okay, so let's actually go down to number 9. Okay, because number 8, number 9, number 10 are all like each other. They're all done the same. Okay, now what we're missing here is we're missing all the angles. So we have no angles. We have all the sides, but no angles in this case. Okay, so we need B, C, and A. So again, here's where we need the law of cosines again. So what you set your law of cosines equal to doesn't matter in this case, at least in the first step. Okay, so I'm just going to choose to set it equal to A. Okay, so I'll make it A squared equals B squared plus C squared. So in other words, it's whatever's left over, B and C, minus 2 times those same letters, B and C, times the cosine of whatever you set it equal to, A. So then I take cosine of big A. So let's go ahead and plug it in. So now 27 squared equals B squared, 25 squared, plus C squared, which is 28 squared, minus 2 times B, which is 25, times C, which is 28, times cosine of angle A, which we do not know. Okay, so now this is where we got to go ahead and solve it all. And we got to solve for A, so we need to isolate A. So let's go ahead and start simplifying. So first, I'm going to do this on a separate calculator. 27 squared, well, that's 729. 25 squared, that's going to be 625, plus 28 squared, 784, minus 2 times 25 times 28, it's going to be 1400 times the cosine of A. Okay, now let's add up 625 and the 784. That's why we have calculators. Some of you saying, oh, these numbers are so big, Mr. Osborne. How could you? Well, that's why we have calculators, ladies and gentlemen. So now let's subtract the 1409 from both sides. 1409. Those two cancel out. And let's see, 729 minus 1409, that's negative 680. Okay, equals negative 1400 cosine of A. And the last thing I need to do here before I do inverse is I need to get rid of this negative 1400. And this time, it's being multiplied times cosine, so I need to divide it. Okay, and I'll divide it to both sides. Okay, so now I'll have cosine of A is equal to, well, remember it's got two negatives here, so those will cancel out. So it'll be equal to 680 over 1400. And now the last step is that, remember, when you're looking for an angle, and if it's like sine of A or cosine of A in this case, you're going to do the inverse of that function. So not cosine of A, but inverse cosine. And you do the inverse cosine of what that is equal to. And cosine of A is equal to 680 over 1400. So you do the inverse of 680 over 400, or over 1400, and that will give us our angle. So now let's go to our online calculator. And now let's do the inverse. So I need to push second on this calculator first. And that gives us arc cosine, which is the same thing as inverse cosine. 680. And we have to go back to the other version. 680 divided by 1400. That looks good up top. Just make sure that looks like what I want it to. Equals 60.94 degrees. 60.94. Sorry about that. 60.94 degrees. And that is angle A. Okay, so I'll put that up here, 60.94 degrees. And remember now, I have a pair. I've got 27 and 60.94. So if that's the case, now I can use sine of cosine. So now let's do set of sine of cosine. I'm going to look for another angle. So sine of, let's look for angle C. And that its opposite side is 28, right here. And then we'll do sine of that angle we just found, 60.94, over its opposite side, 27. And now let's cross multiply. Remember, I can just bring this 28 up to the top here and multiply it. So now I have sine of C equal to 28 times sine of 60.94 divided by 27. And again, here, I'm looking for an angle, sine of an angle, so that means I need to do the inverse sine of this value to the right. So inverse sine of 28 times sine of 60.94 divided by 27, and that is going to give us our angle C. Okay, so C, let's punch that in. So it's sine inverse of 28 let's clear this. Okay, so sine, remember we need to do arc sine on this calculator. Turn the second off, and 28 sine, oops, so we gotta specify that we want it to do 28 times sine, not the sine of 28, and then 6.94, sine of 60.94, and then divide by 27. And then verify up here up top to make sure that looks like what you set up in your problem, and it does. So that equals 65.02. So over here, 65.02 degrees. Okay, now, let's write that up here. So 65.02. And the last angle I've got to find is B. Okay. Well, remember, I've got two angles now. So I know they add up to 180. So if I do 180 minus the sum of both of those angles, then that will give me my last measurement that I need to find. Okay, so that is equal to angle B. Okay, so let's do that last measurement here. Oops. Clear that. Okay, so we're going to do 180 minus 60.94 plus 65.02 and equals 54.04. So our last angle is 54.04 degrees. Okay, I'll write that up top here. Okay, and there is our completed triangle.